over the last couple of days, it became pretty clear to me that we need to talk a little bit more about what a solution to an inequality is. Um, your ability to solve inequalities is pretty solid, but your understanding of what we're actually finding is something that I think we need to take some time on. So I'm actually going to talk more about equations in this video than inequalities, but at the end, we're going to reflect on how that kind of impacts us with inequalities. So we did a lot of work on what a true equation is and what a false equation is. And you've also done plenty of solving of equations. And I think because the equation is a pretty simple idea where there's one value of x that's going to make 2x plus 1 equal to 15, we've done a pretty good job, but we haven't really slowed down to think about what is going on when we solve the equation. So an equation with one variable in it is usually true for the right value of x. And if it's not the right value of x, then it becomes a false equation, looking back here. So we've proven to be very good at this. All that work is to point out what about the equation. When you do that work to 2x plus 1 equals 15 and you get it down to x equals 7, what does that mean about the equation 2x plus 1 equals 15? Well, if we know that it can usually be true, but only for the right value of x, I think that statement is telling you very clearly 7 is the right value of x. And we really haven't taken enough time to go back and show that. So what I'm doing over here on the left-hand side is I'm showing you, look how well 7 does work. What it does is it takes 2x plus 1 equals 15, which we know is an equation with a variable that is usually true for the right value of x. And we're testing the value of x that our equation is pointing to. And it's turning out that when you use that value in the place of x, you get a true equation, just like 6 equals 6. It's a different one. So I want you to note that the x's that are not named there, they don't make it true. The x's that are not named in our solution, they make 2x plus 1 equals 15 false. An example of a number that's not named in that equation is like x equals 11. I could have pulled any number out, but let's take a look at 11. Watch how poorly 11 works with the equation 2x plus 1 equals 15. When we solved 2x plus 1 equals 15, we didn't find an x equal 11. So no wonder x equals 11 as a test value is leading to a false equation. So understand that this line that you get at the bottom of solving equations is telling you, hey, this is the x value that's going to make the equation true. And when you give that answer to someone, you're saying, you gave me a mystery to solve. What value of x makes this equation true? I'm telling you it's 7. Now, we have seen that sometimes these variables, equations with variables, can never be true, or maybe they're true all the time. So let's take a close look at that. Here's an equation including a variable, and we have solved ones like this before, and we've gotten to this point, and we've, for the most part, come to the conclusion that we would say, well, that means there's no solutions. But I think I probably owe it to you to help you with inequalities, to take a look closer at that. So we have boiled down the equation 2x plus 1 equals 2x plus 4 to the line 1 equals 4. And we've told you, hey, just tell me there's no solutions. But imagine we didn't know that. Imagine that we were thinking, well, I see that there's no x's named there, but I'm used to seeing that a number, some value of x is what my equation is supposed to be about. Well, then maybe we would be under the misconception that this 1 equals 4 means something about the equation that it doesn't. Maybe someone would think, maybe they're trying to tell me that 1 was the value of x. 1 is part of what I boiled this down to. 7 was part of what I boiled it down to. Maybe 1's a solution. Well, here's evidence that 1's not a solution. Because when you use 1 in the equation, you get a false equation. Well, then maybe 4. Maybe I just picked the wrong side of the equation and plug 4 in. You plug 4 in for x, it becomes a false equation. So neither of these numbers that were left here are solutions to the equation. They're signals that it's not true. And maybe we're in panic mode. We just grab any x value we could think of. Well, that failed too. Of course it failed. There are no x's that are named here. So no x, it doesn't say x is this. No x's are named there. They're not naming any winners. There are no solutions to this equation. And then we've seen the other side of the coin too. Here's an equation, and when you go and solve it, you get this true equation at the end, and I've told you that that means that all real numbers were going to work for this. Well, let's really illustrate that. This thing here, yes, has 4 in it, but it's not saying 4 is the solution, although 4 does work. Because there's nothing magical about 4. 7 works, and that has nothing to do with the equation. -8 works. Where'd I get that from? Any number seems to be working. 100 works. So when no x's are named in your final line, you've got two choices. Either every number was going to make that equation true. That's if it becomes a true equation, or no numbers were going to make it true. This was one of the cases where we have infinite number of solutions. So let's move on to inequalities now. Inequalities, I think, have been complicated enough that even if we don't get into the all reals and no solutions, I think we need to take a close look at what does this statement mean. But first, we saw some true inequalities, and you guys did a really nice job with that. I think we kind of jumped through all the hoops and we figured out all the little details. And we saw false inequalities too. We covered all the weird cases where 4 greater than 4 somehow is false. Okay, it's because it's telling me they're unequal. We handled this one here where this big looking number like 102, well, actually a negative 102 is more negative. So this is a false inequality. So we really know what true and false inequalities are when there's no variables. Well, let's start looking at inequalities that include a variable. They're usually true for some values of x, multiple values of x. It's not like an equation where there's usually one value of x, like 7. They're usually trying to tell you, look, there's lots of answers here. X can be anything greater than blank. So we've gone through the hoops, gone through the steps, and I think people are doing a pretty nice job of solving these things. But I wasn't really feeling confident that people knew what this meant. So let's look at the solution we got. X is less than -8. What does that mean about the original inequality? The x's that are named there make the original inequality true, just like the equations. Numbers that are not named there make it false. So I think this is our biggest problem right now. We see the -8. We feel like -8 is the number that's being named here, but it's not. The x's that are being named here are every number that is lower than -8. So oddly enough, -8 is not being named. What I want to do is I want to tell you some numbers that are being named down here and show you that at least one of those works. And then I want to talk about the numbers that are not being named in this line, and I want to show you that at least one of those does not work. And we'll start getting a better idea of what this means about our inequality. So here's some x's that are named here. -9. And again, I need you to pause for a second and think, well, how's that possible? I see the number -8. Well, what I'm saying is -9 is one number that's being described here. -9 is one of the many x values that are lower than -8. But that's not the only number lower than -8. Like -10 is lower than -8, and -150 and -10.5. So this inequality is naming lots and lots and lots of solutions for this thing. And if you take any one of those solutions, any one of those numbers that's named here, and you throw it into the inequality, what should happen? It should become true. So I'm just going to simplify the left-hand side, and I find out the left-hand side becomes -450, the right-hand side becomes -302. Is this a true inequality? Absolutely is. So this -150, which is one of the many numbers named over here, is a solution because it makes the inequality true. Let's look at the numbers that are not named. Well, -7. Again, think about what that means. I'm not telling you I don't see the number -7 here. I'm saying -7 is not less than -8. -7 is not named here because -7 is not one of the x's. Neither is 6 because 6 isn't less than -8. 0, even 0 is on the big side of -8, so 0 isn't less than -8. And strangely enough, -8 itself is not named either. Let that sink in for a second. So any of those numbers, if I plug those into the original inequality, what should happen? It shouldn't work. So let's try the most controversial one out of that list, which is -8. What does that do to our original inequality? Well, it makes -24 plus 6 on the left. It makes 2 times -9 on the right. It ends up with -18 equals -18. And think for a second, is that a true inequality or a false inequality? It's one of those strange false ones. So a number that is not named here made the inequality false. So I need you to start thinking about these things as a list of numbers that make the original inequality true. And it's kind of like, no wonder we ended up drawing this picture now. What you're doing is you're drawing a picture of the solutions, and there's so many of them. It's almost better to just say, hey, here's my solutions. They're all to the left of -8. They include -9, they include -10. And because they stack up on top of each other so much, like evidenced by the negative 10.5, you just kind of shade that side in and you kind of fill in all those dots. So here's our summary. Inequalities containing variables are usually true for a lot of values like we just saw. So go ahead and solve the inequality like any equation, unless you multiply or divide both sides by negative. We know that reverses the inequality. And if a variable remains like in the one we just saw, you now know what values make it true, and you can describe them, or you can draw a picture. So you can just give the description, any number less than -8, or you can draw the picture. And I didn't show it, but I'd like you to think about it. If the variable disappears, like the ones were with the equation, we're back to this like, well, it must be all numbers were going to work or no number is going to work. It's not pointing any x values out. It's saying, look, this thing was false on its own or true on its own. So I hope that helps a little bit. I think it was an important thing, and now we can kind of get to some practice, and we'll work together to figure out which are the best problems for you to try.